All right, there we go. Got it. All right. All right. Hello, everybody. Hi. Hello. Hopefully, everybody's doing well today. Sorry for the little delay there. I was just trying something different, and yeah, it didn't work out the way I wanted to. So, rather unfortunate, but oh well. It is what it is. Can't really do much about that. But no worries, I'm still here, so. All right. Any case, how's everybody doing today? Good. Very happy to hear that, Stacy. I'm glad to get in at the end of the week now, so we're getting down to the final throes of this chapter. Very good, Marisela. I'm doing really good. Doing very, very good today. Just been a nice, comfortable, relaxing day. I think that's what we all need. Got a little work to do, but not too much. Okay. Well, we'll wait for, well, actually, other people will start coming in, I should say, but we're going to go ahead and get started. So, okay, let's go. Let's get started today. Welcome back to Thursday, end of the week time today. So today, we are going to start where we left off last time. Last time, we talked about how to round numbers. Okay, we talked about kind of using the circle and kind of underlying method. We're going to finish up that last part of the section here, which is section 1.7, talking about how to round here. We're doing calculations with rounding. That's what we're going to be doing there. We'll also be talking about exponents and square roots and order of operations as well. And if we have time, we're going to get into a few application problems, which will be from the last section in chapter 1. All right, so we're getting close to that time where I'll be making that announcement for the first test. So we're getting to that point right there, so it shouldn't be too bad. Okay, well, let's go ahead and take a look here at our handout uh, from our handout here. So let me bring this up here. Okay. What sections are we going to go over today? We're going to do the latter half of 1.7, we'll do 1.8, and we may get started with 1.10. So I'll go ahead and get started here with the rounding stuff, and we're just going to pick up where we left off from last time. Okay, so in section 1.7, at the latter half of section 1.7, that's going to be on page 56 on the handout there. What we want to do is use rounding to estimate the answer, and by doing that, we want to round to the nearest 10. Okay, so each one we have to round to the nearest 10. So we're going to round each number here to the nearest 10, and then we're going to go ahead and add, subtract, multiply, divide, whatever we need to do in order to actually find that answer. And again, we're not going to get an exact answer here. That's not the point. The point is to get to an approximate answer because we'll be rounding off every number before we add or subtract or multiply or divide. So the calculations here are going to be significantly easier as a result. All right, so let's take a look at that first one that we see there. All right. Oh, I meant to hit this. There we go. So basically, so I'll say operations with rounding. Okay, so let's look at that one there. We'll do the 76 plus 53 plus 38 plus 91. Now, like I said, there's an exact answer to this, but we're not finding the exact answer. So Just a note here, we're going to round each number first. Okay. Note number 2, we are not finding the exact answer. Okay, that's important there. Okay, so let's look at each one here. Let's look at 76. We want to round this to the nearest 10. Okay, that's what it asks us to do. So if we're rounding 76 to the nearest 10, what does 76 round to in this case? If we're rounding it to the nearest 10, 80. That's right, right? So we look at 7, that's the tens digit, right? We then underline the 6. Since 6 is between 5 and 9, we round this up to 8, and then that 6 changes to a 0. So we're using those same rules that we talked about on Tuesday, all right, in order to switch those numbers over. All right, let's keep going. How about 53? What does 53 round to? Okay, great. That's right. So the answer definitely is 50. All right, so far so bueno. Let's look at 38. 38 rounds to. Okay, so 38 is going to round to 40. All right, so again, that's just going to go up. Again, you have an 8 next to the 3, and then you should be good to go there. Good. And then we got this last number here, which is 91. What does 91 round to? Yeah. Good. So that looks just fine. Okay, so now all we're going to do is add up these numbers that you see here on the right together. That's all we're going to do. We're going to take 80 plus 50 plus 40 plus 90. And then we're going to get a result here. So let's kind of go down the line here. All right, let's go ahead and see what we get here once we add these together. Oh. So what do we get here? 80 plus 50 plus 40 plus 90. We have basically we got 0 here, and we just have to add all the numbers. 8 plus 5 plus 4 plus 9, 260. Okay, that's correct. 260. That's right. So if you take these, 8 plus 5 is 13, 13 plus 4 is 17, and 17 plus 9 is 26. And then you tack on the 0 there because you add 0 at the end there. So 260. Good. That's correct. All right. Any questions about that? Give me just a second here. I'm just going to grab some water. Throat's getting really dry. Give me a second. Sorry about that. Just needed to get my gallon full of water because, reasons. Gets really dry in my little place, so all right. Apologies. Okay, let's go ahead and try another. All right, let's try that's nice. Let's try okay. So let's try this one here. We're going to do, I know this is on like 2 separate pages here, but we're going to try that. So we'll try that letter C that you see there on the screen. So we're going to do 664, and we'll multiply that by 834. So 664 times 834. All right, so before we start here, let's go ahead and round these numbers here. We're going to round these according to this problem here, I believe. Yeah, we're going to round to the nearest 100. Okay, so we're going to round to the nearest 100 here. Okay, so let's see what happens here. So rounding to the nearest 100. So 664, what does that round to? If we round to the nearest 100. Okay, 700 is correct. Right, so we're going to look at that first 6 that's in the 100 spot, and then we underline the 6 that's next to it. So that means that since that's between 5 and 9, we bump up that first 6 to a 7 and change everything else to zeros. Okay. All right, how about 834? What does that round to the nearest 100? $800, that's right. Nice. Okay, so now we're just going to multiply 700 times 800. But here's the nice part about this, okay? The nice part about this is that you can take a little shortcut just multiplying those two numbers together. You first figure out what 8 times 7 is. So let's do that. What's 8 times 7? What we got there? 8 times 7. Just that part there. 56. That's right. So we're going to start with 56, and then we're going to tack on as many zeros as we see. So we have 1, 2, 3, 4 zeros. So we're going to tack on 4 zeros after 56. So 1, 2, 3, 4. So our final answer here is 560,000 as our final result. So with zeros at the end, since we rounded things off, that makes the calculation significantly easier, as all you need to do is tack on as many zeros as you have and then multiply just the regular numbers together. So you can pare down that problem pretty fast without having to do as much work as you would normally do. Okay. Are there any questions about that? No? Okay. All right. No problem. Okay, let's go ahead and try, let's go ahead and see if we can do another one here. Okay, so let's go ahead and do what we're going to do next here is what's called front-end rounding. Okay, so we're going to use front-end rounding here to estimate an answer. So what exactly is front-end rounding? Well, we're been doing the same things, plus, minus, times, whatever. But front-end rounding, to be a little bit more specific, is where you round using the first digit of the number. Okay, so basically front-end rounding is you round using the first digit of the number. So basically that's the one you want to use and then take the one to the right to do a check. So each one of the numbers here could be different in terms of front-end rounding. Let's go ahead, I'll show you an example here, and you'll see what we're talking about. So for this one here, I'll get out the paint tool so it's a bit easier to kind of follow along. Okay. All right, so I'm going to do the one that you see here on the screen, the 2583 minus 765. Now again, our goal is to not actually figure out the exact answer here, but our goal is to round and then subtract. So the method is the same, but what we're going to be doing here is going to be slightly different than what we just did. Now, in the previous example, we had every number here be rounded to the nearest, say, 100 or the nearest 1,000 or the nearest tens, whatever the case may be. In this case, we're going to use front-end rounding. So in front-end rounding, like I said, we're going to round this first digit we see here. So I'm going to round the 2 and then look at the 5. I'm also going to do the first digit here for this second number, so I'll circle the first number, the first digit, and then underline the 6. What's my YouTube? You can look up my YouTube underneath the so my YouTube is underneath Professor Chibs. So you can find all the replays underneath that. Though Twitch should work. Twitch usually works for pretty much everybody. It's a pretty easy platform to kind of work on a computer. Ah, sorry about that. Yeah, I forgot. That's give me a second here. Hang on. I'm gonna quickly. Yeah, I gotta do something about that. Shoot. Give me a second, DarkSync. Yeah, Twitch blacklists links unless you're made a moderator. So there, I'm gonna mod you, and then you can post the link if you like. So there you go. I'll just unmod you for that. There we go. Thank you, Dark. Yeah, I just modded you and then I unmodded you, so you should have it now. I hope so. Yeah, because Twitch usually works for most people. All right. Okay. Let's look at each number here. So we're gonna round each number here. So let's look at 2583. Okay. So 2583, what does that round to? You know what, Dark? I'll just mod you anyway. I'll just put you back as a mod. Here you go. Now you're mod again. All right. What is 2583? What's that as what if we round that? What is 2583 going to round to? So all right, 3000. That's correct. Okay, 3000 is correct because again, you have the 2 here. Again, you look to the right of that. We have a 5 to 9 there. All right, and so we round that up 1, so we get 3, and then we get 3000 there. All right. How about 765? What does 765 round to? Very good. That's right. Nice. Yeah, no, you're right, Yvonne. 800 is correct, right? We have the 6 next to the 7, so that means that we bump this up by 1 to 8, and we get the other zeros. So absolutely right, Yvonne. Very nice. That's okay. Don't worry about it. Yeah, thanks for joining us, Assassin. Okay, so here we have 3,000 minus 800. So what's our answer here for this one? 3,000 minus 800. What's that going to be? All right, very good, right? This is 2, right? Yeah, that's spot on. This becomes 2 because we borrow 1. So 2,200. That's right. Nice. And that's our final answer for that. So you can see we just kind of use this very front number here, and then we're able to put that together, no problem. Okay, let's go ahead and try this next one as well. I want to do just a couple, just 2 of these, so that way, again, you know what front end rounding is. Again, this is with front end rounding. Okay, so here we have 648 times 67. All right. And again, we're not finding the exact answer here. We're rounding it. So again, we're doing front end rounding. So again, we're going to circle that front number here, that very first digit. So each one of these 6s. We'll underline the number to the right of that, which is what we talked about last time. That first number there, yes, Yvonne, we'll round to 600. Spot on. I agree. Very good. I certainly agree with that. How about that next number there? 67. What does that round to? 670. Yeah, nice. All right, cool. All right, good beans. Okay, let's take our little shortcut approach. Okay, so we just want to figure out what 6 times 7 is, and then we'll tack on all the other zeros at the end. So can anybody tell me what is 6 times 7? That's right, 42. And then we'll just see, you see you have 1, 2, 3 zeros. So we're going to tack on 3 zeros at the end, just like so. So our answer here is 42,000 on the money. Okay, good. You can see how we just kind of put it together piece by piece. Not too bad. Just takes a little time getting used to, but you know, pretty reasonable if I would say so myself. So, pretty reasonable. Are there any questions about these couple examples here? No? Okay. Well, if there are no questions here, that was the last part of section 1.7 that I kind of wanted to show off there. Just doing a few calculations and whatnot. All right, so we're going to go right into section 1.8 now. All right, we're going to talk about exponents and roots and order of operations. All right, so let's talk about each one of these and let's see how things work out. Okay, so let's start with section 1.8. So exponents, roots, and order of operations. All right. So the first thing we'll talk about here, as we see there, is exponents. Okay, so what exactly are exponents? Well, first of all, I guess we'll just answer a better question here. What do exponents look like in general? Well, exponents in general are going to be like you take some number, we'll call it, let's take some number here, we'll call it 4, and you raise it to a power, let's call it 3. Okay, so we have, say, 4 to the third power. This would be an example of an exponent. In general, you have a number here, and we'll describe what this number is, so that's just with numbers, but in general it looks like this. B to the, let's say B to the n power here, okay? So this is what most exponents kind of look like, some number to some power. Now, we do have a name for each of these, so that's why I kind of wanted to at least point this out. All right, so to point this out here, B here is specifically what we call the base. So this is like the base of the exponent. And then n is going to be the exponent itself. Okay, so that's what each one of these is going to be. Oh, thank you, Captain. I really appreciate that. That's really kind of you. Okay, so let's take a look at how it works here for exponents, okay? And kind of look at kind of breaking it down here. Let's start off with something basic and we'll work our way up. So let's go with something simple here, like 3 to the second power, okay? Simple enough, not too bad. Now, if we're going to think of it in terms of practical use, 3 to the second power, the exponent here reflects how many times you're multiplying the base to itself. So that's what the exponent does. Exponent just talks about how many times you will multiply the base with itself. So if we look at 3 squared here, 3 squared, all that reflects is just 3 times 3. We're going to multiply 3 by itself, all right, two times. So you see here, 3 times 3, there you go. And then you do 3 times 3 here, which is 9. Okay, and then you could evaluate it and do whatnot. Same thing if I had, say, 5 to the third power. That would be 5 times 5 times 5. Okay, 3 5s. We're multiplying the base 3 times with each other. And there we go. And if you do 5 times 5 times 5, you'll actually figure out you'll get 125. Like that. Now, I don't expect you to like completely memorize that, but again, it's a common one that we see quite often. So that's how, essentially, how basic exponents work. Let's try another one, though. I think another one's in order. So let's try 2 to the fourth power. So first of all, how would I write out 2 to the fourth power? That's how I would write it out, yes, but I mean just breaking it apart. Stacey got the right idea. That's what I wrote up there. But yeah, that's what I'm looking for there. Yeah. Right. Perfect. Okay. Correct. So 2 times 2 times 2 times 2. Right? 4 times, right? Because that's the exponent. So in your head, you're like doing 2 times 2 times 2 times 2. Right. And then let's go ahead and multiply 2 times 2 times 2 times 2. So again, if you need to take it in steps like we did before, you can do that. Just do it, one at a time. So, but can anybody tell me what we get here as an answer? Yes, that's right, Jonathan. Very good. 16 is your answer. So 2 times 2 is 4. times 2 is 8, times 2 is 16. So there we go. We got it. So we can see here that at least for exponents, they're not too bad. Okay, they take a little getting used to, but pretty straightforward in terms of how we want to approach the calculation behind what we do with exponents. Okay, so that's not too bad. There's a lot of rules to exponents, but we're just focusing on basics in this class. If you're going on to the next level there, you'll be learning more about the rules of exponents a little later on. So in any case, just doing the basic stuff here. All right. Well, that's fine. Okay. Now, let's talk about the next part here. All right, so we're going to talk about the next part here, and this is going to be rather important. We're going to talk about roots, okay? Now, you probably have heard of roots before, like square roots or whatever. All right, so by itself, it's not too hard, all right? But what I'm going to put up here on the screen, this is on page 60 of your handout. This is actually really important. This table here is a perfect squares table, okay? These are all the perfect squares, meaning to say what's 0 squared, 1 squared, 2 squared, 3 squared, and so on up to 15. You could technically do it up to 20. You tend to see up to 20 the most in any regular old textbook. But these 15 are what we're going to focus on here at the very least. Let's talk about how square roots work, though. What's the key here? One of the things is to understand is that memorizing this table here that you see is actually going to be one of the important things, not just for this class, but for future classes as well. It makes calculations that much faster if you're doing square roots of that. All right. In any case, let's talk about how we can evaluate square roots and exactly what we're working with. Okay. So I need to bring this up here. Okay. And I'll bring that up there. So let's talk about the key behind square roots. Square roots, basically, as you know, the notation here, really quick. So notation for square roots, as many of you are probably aware of in some form or capacity, and if you haven't used it in a long time, or haven't used it much, then that's okay. But you've all seen possibly the square root symbol in some form or fashion. So there's the square root, okay, as a symbol. All right, nothing too fancy. It's there. And as I said here before, well, how do we evaluate square roots? What's the story behind that? Well, the way it works is, what's the key here? The key is that in every time you evaluate a square root, it doesn't matter what square root it's going to be, but every time you evaluate a square root, all right, you're going to ask yourself the same question, okay? So the question goes like this. If I have, say, the square root of, let's take the square, let's put this in here. Let's say I have the square root of some number a. I don't know what that number is, but it could be, it could be some random number for all we care. All right, so if you want to figure out what the, let's say in this case, so if you want to figure out if the square root of a is equal to something, all right, then what you're going to do here, then figure out, and this is the key part here, so I'm going to be a little bit more succinct, is that some number, what number squared equals that number underneath the square root. That's the biggest key here. So there's going to be some number squared is equal to that number underneath the square root. And this is the question you ask yourself every time you're doing a square root there. It's like, is there a number that I can basically square to get that number on the inside? Okay? So let's look at an example. Let's look at several examples, I should say. And let's figure out if there is a number that indeed exists. Okay, so let's start off with 9. So the square root of 9, okay? So again, if I'm figuring out the square root of 9, this one's not too bad. But again, I'd make a little more space here. We're just figuring out, well, what number squared equals 9? All right. So what number squared is equal to 9? Now, if you're not sure, it's not about 9 here, but if you're not sure about what that number is squared is equal to whatever number you have on the inside here, since we're dealing with basic roots here, not something more complex, take a look at your chart. And you can see, based on the chart here, you can see what number squared is going to equal to 9. Okay, so what do we get here in this case? So the square root of 9 would be what? What do we get here? Okay, that's right. All right, very nice. The answer indeed is 3, right? So we could say 3 squared is equal to 9, all right? So 3 squared is equal to 9. Again, as you see here, if you're taking a look at your table, see if we have 9 here equals 3 squared. So that's what we have here so far. Let's try another one. How about the square root of 25? What's the square root of 25? Five. That's right. The answer indeed is 5, right? Because as we see here, 5 squared is equal to 25. Good. It's like, again, what number squared is equal to 25? Okay, the answer is 5. Let's look at another one here. Actually, we'll do that next one I see there. Square root of 0. The square root of 0. That's correct. Right, 0. Nice. Spot on there. Okay, let's try one more. How about the square root of 169? The square root of 169. $13. Very good. Nice. All right, gotta say that at least once. All right, so well, I mean, you know, if the first part of your username is 420, 69, 69, 420, yeah, I think everybody's heard that joke before. Get used to it after a while. All right. Okay, are there any questions about square roots? Do you want me to do another example there, Yvonne? I'll be more than happy to. Sure. Let's do another example, okay? Sorry about the noise outside there. I guess they're trimming the bushes and stuff out there. So apologies for the extra noise. Okay, let's do the square root of 196. So again, one more time here. What number squared equals 169? Or 169, 196. I got that backwards. All right. Hi, how you doing? Didn't think you'd be up so early. Had a long night yesterday. How can you find the square root of a really big number? See what it's divisible by, and keep reducing it down. If you can't use a calculator, see what start with the basic number here. Oh, it's 5 p.m. Oh, I guess my time. I guess my Germany time is kind of off there. All right, so take a look at the list here. All right, so we want to say what number squared is equal to 196. And if we take a look here on the list, we can see that 14 squared is equal to 196. Okay? So but yes. We're doing a class there, buddy. So just showing off how to find that, my friend. Okay. So as you can see here, 14 squared is equal to 196. So the answer to this is going to be 14 as a result. So we're just trying to find out what number squared is equal to 196. That's okay, man. It's all good. Yeah. So what you're gonna do there, Yvonne, is to reference the table to find your answer for the square root. We're just dealing with basic square roots. When you go to like intermediate algebra and stuff like that is when you're going to see more advanced examples. But we're just dealing with kind of basics here at the moment. So reference this table here, and it should be able to help you to go ahead and find those square roots. So like I said, you'll be using this table here more and more and more, and you'll be working with higher powers as well for other types of roots. So that's kind of the more advanced stuff, but we're not going to be dealing with that here. We're just dealing with basic stuff for now. Are there any questions about that? No? Okay. All right. That's perfectly fine. All right. Okay. So let's look at the next one here. The next part that I want to do here is going to be, let's see, order of operations. Okay, so let's do order of operations. Okay, now let's go ahead and take a look at an example here. All right, and I want you to go ahead and answer this question in the chat here. So I'm gonna write this question here in this math type, and then you guys tell me what the answer is. Okay, so to talk about order of operations. So thank you. I appreciate the kind words. So All right, so you guys in the chat here, can you tell me what 6 divided by 2 times 3 is? What's that? What's this expression here? What's this equal to? I get 1. Let's see, 9. 9. 9 there. Okay, got one or not. Got majority 9s here so far. Let a few more people answer, of course. I mean, like I said, I agree it's one of those two answers. I agree with that. Anybody else want to chime in? Do they think it's 1 or do they think it's 9? Yeah, dude. Yeah, dude. That's nice. 9? All right, anybody else? 9 for that? Okay. So the answer got 1 and 9 here. And again, I do this on purpose here. But the answer to this question here is going to be indeed 9. That is correct. Okay, so let's talk about that here. The reason why I highlight this question is because there's a common misconception about order of operations that you may have been taught in the past. Now most of you have actually picked up on that, but let's go over and see exactly how we had that. All right, so order of operations, first of all, is with as you know here, PEMDAS. Okay, yeah, well done, very nice. All right, so P is for parentheses. All right, P stands for parentheses. Let's actually, I'll put that on the next page here. Okay. What does E stand for? What does E stand for here? We just talked about it like 5 minutes ago. Yeah, exponents, that's right. How about M and D? Multiplication, division, okay. So I'm going to write this in a very particular way. All right. And then finally we have addition, subtraction. Okay. Now one thing I want to highlight here is the multiplication and division part. Yes. Now if you notice how I wrote it on the same line. I wrote multiplication slash division. And the reason is because one of the common misconceptions you may have been taught a long time ago is that, oh, well, M becomes for D, and so multiplication comes before division. But that's not true. The issue is that actually multiplication and division are the same rank. Okay? Multiplication does not come before division. They actually are the same rank. It's like if you did, if you did this, if you did like 6 minus 2 plus 3, for example. Well, if you did that and you added subtracted, you would just go from right to left, left to right, excuse me. And the same thing would apply for division and multiplication. I just go from left to right and just do it in order. Like, so this would be like 6 minus 2, 4, plus 3 would be 7, and that wouldn't be a problem. So why don't I approach this the same way? If I approach this the same way from left to right, then I do 6 divided by 2 times 3, right? And then, so I say 6 divided by 2, which is 3, and then I do 3 times 3, which is equal to 9. All right? So order of operations mean a lot here. If there were parentheses around, say, 2 times 3, then I would agree, yes, that's what you would have to do first, because parentheses come first in an order of operations event. Okay? Now, there is one exception to this rule. All right? So let's talk about the one exception here to this rule. So, but actually, let's do a couple of these examples here first, and let's see what we're working with. All right, so let's look at this first one here that we see. We see 8 squared plus 5 plus 2. Okay. All right. Okay, so let's go down the line here. What's the first thing that we have to do here? What would 8 squared be? Let's just see again, right? Exponents would have to come first, right? $64, that's correct. You're on timeout for a minute. All right, so we get 64 plus 5 plus 2, and what does that equal? 64 plus 5 plus 2, what's that going to be? 71. Good. That's right. So that one's not too bad. Again, we did the exponents first, and then we go ahead and proceed to go on from there. Okay, let's go ahead and take a look at the next problem here. Yeah, let's go ahead and do this next one here. Henry, if you're not going to act like, look, if you're not going to act like an adult, all right, I'm going to treat you like a child, and you're going to be put on timeout permanently. I'm just giving you a fair warning here. This is your one and only warning. Otherwise, I'll put the band hammer down. I'm not afraid to use it. Okay, so I want you to take a minute here and see if you can do this problem here. Okay, don't forget you want to do parentheses here first. Okay, so we got 9 plus 20 minus 4 times 3. So Yvonne got 75. 75 for that. Okay. Not quite there. Not quite there. Be careful for that first part there, Yvonne. Remember, parentheses have to come first, Yvonne. That's part of the process there. So again, if you need to give yourself a little reminder here, remember PEMDAS, okay? All right, so 57 is indeed the correct answer. So let me go ahead and show this off here. 20 minus 4 is 16. 16 there, right? So this should be 16 here if we're doing parentheses first. Yes, it is. All right, so this is 16 here, and then we take the 16 and we multiply by the 3, because again, multiplication comes before addition. So I know that I know the common mistake here, and this is, I'm glad that this is, we're getting this dialogue out, because again, we always think we go from left to right, but remember, we have to look at priority as well. So we did parentheses first, then we have to do multiplication, and then we do the addition there. So again, that's why we have the order of operations, because we look at the priorities there, all right, in that particular case. So here we actually do 9 plus 16 times 3, which is 48. And then we go ahead and add those two together. And that's where we get 57 from in that instance. Are there any questions about that? About kind of how, kind of we're doing kind of one step at a time following the priorities here? This is going to be very important to doing the order of operations here. So I just kind of want to point that out. Yeah. Just clear up any misunderstandings. That's fine. Okay. Now I'm going to I'm going to do that. All right, let's look at this next one here. We're going to do 12 times the square root of 16 minus 8 times 4. All right. Now, I do want to point one thing out here regarding the square roots. Okay, so I'll put that as a note here. All right. So note, square roots are treated as exponents. Okay, so square roots are treated as exponents. All right, so just to let you know, square roots will be contained within exponents. All right, so that way you'll understand where the priority level of square roots are going to be. So let's take a look here at this problem. Let's break it down together here. So if we're doing this, what should I do first? What do you think I should do first in a problem like this? Okay, we could do the 8 times 4. That's fair. We could do that. We haven't done the square root of 16 yet, but we could do that. What's 8 times 4 there, Yvonne? All right, 32. So we have 32 here. What do we have to do next? What do we do next? Square root of 16. Okay, good. What's the square root of 16? So what's the square root of 16 here? What is the square root of 16? So again, what number squared is equal to... All right, very good, Dark. That is correct. Okay, so the answer to square root of 16, what number squared, is going to be it's going to be 4. All right, so here we get 12 times 4, and then we have the minus 32 here. Okay. Okay, what's next? What do we do next? What's the next step here? We're just going over this problem really slow, so that's fine. Again, 12 times 4, perfect, Yvonne. All right, so 12 times 4 is? $48, spot on. And then finally we have 48 minus 32. 16, right. So the answer is 16. Very good. Very, very nice. All right, and that's going to be our final answer for this problem. Good. Froze for a second there, so I apologize. Okay. Hopefully just a small hiccup. I haven't had any problems, so small hiccup in the thing. Oh, maybe again. That'd be pretty bad. Let me check. No, that's okay. You know what? It's fine. If worse comes to worse, I'll just make an adjustment there. Okay. All right. Any questions about that example there? Let's see if they have that. No. Okay. That's fine. We're fine there. Okay. All right. Let's have you guys try another one here. All right. Actually, which one do I want you to do? Yeah. Why don't you give this one a try here? Okay. Go ahead and give this one a try. So it's a little bit of a tougher problem here. So 4 squared times 2 squared plus 7 plus 3 times 2. All right, so I'll give you guys a minute here. Go ahead and give this problem a try, and then we'll go through it together here. So again, give it a minute. I'll give it a minute or two here. Again, just work methodically. That's all I ask. In the meantime, probably should turn on a fan. All right. Sorry about that. All right, so Maricel says 84. Okay. Anybody else have any other answers here? Yeah, 84. The 74. Okay. So we got a couple 84s, 74. We'll wait for a couple more answers there. Am I teaching a class at the moment? Yes, but you're feel free to watch, and if you have a question, then please go ahead and ask. Not a problem. 84. All right. Anyone else? Any other answers? $84. Okay. Change it to 84. All right. Okay. Let's take a look at what the answer is. Oh, so let's see what we're working with here. So, not the nicest thing in the wide world, but boop, got it. All right. So here we get 4 squared times 2 squared. then I'll go ahead and put the 7 plus the 3 here, and times 2. Okay, so we do the parentheses here first. So we do the 7 plus 3 here has to come first. That's going to be 10. All right. And after that, we have 4 squared, which is 16. And then we have 2 squared, which is 4. All right. So the next thing is that we're going to multiply each side here. So we're going to do 16 times 4. 16 times 4 is 64. And we're also going to do the 10 times 2. Remember, these are separated out by this plus sign here in the middle. So here we get 20. And as correctly stated here, our final answer here is going to be 84. That's right. Very nice. So again, think about the amount of time it took you. It could take you about a minute or two, and that's fine. But as long as you went methodically and slowly, you got to your final result there of 84, and that's how you arrive at your final answer for this problem. Factoring out polynomials. It's actually not too bad. So I like factoring polynomials. Are there any questions about that problem there? We're just going to do one more example here, and then we should be okay. So I'm going to do that bottom example there. Okay, so, oops, that should be times, shouldn't it? Not minus. Oopsie. So let's do this last one here. 15 times the square root of 9, sorry. And minus 8 times the square root of 4. All right. So let's take another minute here. Let's have you figure that out. All right. Let's give it a go. What part of factoring polynomials, Ja? Yes, but it's easier just to do what's inside the parentheses first. It would make it more confusing if you split it up that way. You always want to consolidate first within parentheses before actually doing multiplication if you can. By the way, Ja, did you use the rational zeros test? Or synthetic division? They want me. Oh, they want you to use AC? Oh, okay. Okay. Hang tight for like 5 minutes and I'll help you out with the problem. All right. Yeah, cool. That's okay. Yeah, no problem. Okay. So let's take a look here at this problem. Does anybody have an answer? Is that one answer here at 29? Anybody else have an answer for me here for this problem? Okay, you got 29. All right, anybody else? Anybody else have any answers? 29, okay. All right. So let's take a look here and see if it indeed is 29. So first and foremost here, we're going to take a look at, we have to do the square roots first, because again, square roots are dealt with like exponents. So the square root of 9 here is going to be 3, right? 3 squared is equal to 9. We also have the square root of 4, which, as we can figure out here, is going to be 2. 2 squared is equal to 4. Next, we're going to do multiplication. We have 15 times 3, that's 45, minus 8 times 2, which is 16. And if we take 45 minus 16, that indeed nets us with 29 at the end of the day. So 29 is the correct answer. Okay. All right, so questions about order of operations. Any questions at all? Again, if you have a question, type the question in chat or just type no and I'll move forward. Okay, wonderful question, Jonathan. When is the first test? Okay, so let me give you a rundown about that because I was just about to talk about that first exam. Okay, so this is 1.8. We're going to be doing on Tuesday section 110, and that's the last section here in chapter 1. So the test will be due a week after next Tuesday. All right, so that will be specifically, pardon me, that will be the 22nd. Okay, so that's when the test will be due. So I'll be posting the test on next Tuesday, and then it'll be due a week after that point. That should give you plenty of time. I'll be talking more about the test next class, about kind of what the expectations are and whatnot. So I just have to do a little bit of preparation and stuff. They're a test. I need to leave now. Well, not for you, but for the people who are signed up for the course, yes. So yeah, I'll be making an announcement once we're done with this exam. Uh, Once we're done with 1.10 on Tuesday, and then you'll have a week to finish it, and then I'll talk about the rules and all that jazz, and then we'll proceed from there. So that's the game plan here. And tests will be a little bit more frequent. I know chapter 1 takes a little bit of time to do, but once we get past chapter 1, the chapters are shorter, so they shouldn't take us as long. The test is in my math lab. Yes, that is correct. The test will be in my math lab. I will show you exactly where the test is. I'm going to go over that in more detail and again talk about what my expectations are. Yeah, it will be, yes, for sure, for sure. So I will be talking about that and posting an announcement on D2L in regards to that. So I'll post an announcement saying, hey, the test is due on the 22nd or something. Like I said, I try and pace it out so that way we do it. I want to always schedule the test after we're done with the material so you're not missing anything. So that wouldn't be very fair if I give you a test with missing material. So yeah, so that's kind of like a do you have to turn on all of the work? Yeah, I'll talk about what we're going to be doing here regarding the work behind that. So, to give you a little bit of rundown at the very least, um, what all assignments do we have to do? So everything in Chapter 1, so Section 1.1 to 1.10. Yeah, so Section 1.1 to 1.10. So let me go ahead and put that down for the assignments there. Sections 1.1 to 1.10, skipping 1.9, of course. Yeah, not Chapter 9, just stuff in Chapter 1. Okay? Just stuff in Chapter 1. That's it. And that'll be due the day that the test is due. So that too, the Chapter 1 homework will be due on the 22nd as well. So just pointing that out to you is like, oh, this didn't come from nowhere. The Chapter 1 homework specifically will be due on the 22nd, the same day as the test will be due. So that way you know that you'll cover the homework there, and then at the same time you'll do the test for that relevant chapter, just like it says in the syllabus there. Now, there will be an expectation there. Jonathan's question, the work that you'll turn in to me is like you'll send me a scanned copy or something like that of your work for the exam. So um, you'll get I think I'm going to put like a couple retries, put a slight time limit there. Shouldn't be like a huge big deal for the time limit stuff. I don't really like time limits too much, but maybe I'll give you I'll give you more than enough time to finish off the test, maybe 3-4 hours, whatever. But you get like one retry, and then the best score is basically the score we're going to go with, and then you just send me the work behind that. So yes, that's correct. So I'll be setting up a Dropbox assignment in regards to that. So you're going to show me the work on how you got to that point. So I need to set up a Dropbox in regards to that first test there. You'll submit that work to me. I'll take a look at your work, take a look at your test there, and then yeah. Just the test. Only the test, Maricela. Only the test. Yeah, I don't need to see scans of the work for the homework, no. Just for the tests. Because there's a lot of homework assignments. So, yeah, just the tests, and then we should be good. Any other questions? I'll be talking more about this on Tuesday, so I'm just letting you know now. But kind of what's going to be happening here, because I know we're getting to that first milestone point here. So any other questions? All right. So if there are no more questions, we're gonna end off here. You can wait till okay, that's fine. You can ask me whatever. So yeah. So we're gonna end off here for today. So we'll restart back up at section 110. Remember, we're not doing section 19. All right, and I will see you all on Tuesday. If you're here for my 11 o'clock class, please stay on my stream. I will be doing the 11 o'clock class in 10 minutes. All right, so I'm going to keep on stream here because you have a good one, okay? I need to answer Jawa's question about the AC method, so I'm going to go ahead and do that as well. So, all right, for those of you who want to go, you're free to go, and I'll see you on Tuesday. All right. In the meantime, everyone have yourself a very good weekend, and I will see you then. All right. You take care of yourself, all right? Yeah, see you later. All right, Java. Can you give me an example, by the way, Java, of one of your problems that you'd like me to factor using the AC method? I could use a lot. There's a lot of examples. I just want to use one that's relevant to your homework or whatever. So, Sure. That's fine. It's not a big deal. Go ahead and take a look at one here. Okay. Tell you what, Java. Let me go ahead and put one up here, and then I'll go ahead and explain things through. Okay. Oh, okay. Let's do that. Oh, okay, okay. Yeah, that's okay. Gotcha. Gotcha, buddy. Gotcha, gotcha, gotcha. All right, let's put that up. X squared. X squared plus 22x plus 4y squared? Oh, yeah, okay. I was going to say, I'm like, oh my gosh, please. Oh, you're going to scare me there. All right. And you got to find the roots, right? Or you have to find the, you have to factor, I should say. Yeah, factor it completely. Okay, gotcha. All right. So let's talk about how to do this out and see if we can, because it's possible. See if it is possible, I should say. Okay. So the way I kind of approach this is if we want to figure out, actually, let me think. Are you sure there's a, really quick here, are you sure there isn't a number in front of x squared? Did you look at that problem again? You sure it's 22x with the 4y squared there? Yeah, that's true. I know that. Could you look at that again? You sure it's just 1 as the coefficient for x squared? Take a look at the number in front of x squared. Is that a 2 or is that a or anything like that? Just I just want to be sure there. Oh, okay, okay. Hang on, hang on. All right, let me make up a polynomial here. Make up a polynomial like this. I was gonna say, I'm like, yeah, that's a little awkward there. It's okay. I'll write out a polynomial and then I'll write out a polynomial like a quadratic or something like that, and I'll show you how this works. Okay? So just kind of follow what I'm doing here. All right, so I'm gonna go with 5 or 6. Yeah, that still wouldn't work. All right. So I'm gonna show off this problem here, Java, and then hopefully this will help you understand how this works. Okay? And I'll show you kind of the variation behind that as well. Is that okay? Okay. Okay. So this is 4x squared minus 13x plus 3. And we have to go ahead and break this down appropriately into, as you say, two binomials. And we're going to use the AC method in order to do that. All right, so let's break it down step by step here, okay? So the first step here, step one is we're going to go ahead and basically have A times C. So we're going to do A times C. So A here is going to be 4, B is minus 13, and C is going to be positive 3. So we're going to do 4 times 3. And that's going to be 12. Okay? So that's the first step here. Just do A times C. Simple enough. All right. Step 2. Step 2 is we want to find two numbers. So we want to find two numbers. So we want to find two numbers that, first of all, that multiply to A times C from the first step, and add up to B. Sorry for the handwriting. It's kind of hard with the paint tool. So in this particular case, what I'm kind of wanting to show off here is that in step 2, I'm going to put a couple of blanks here, okay? So I'm going to have one blank times another blank equals AC, so that should equal 12, right? Be careful about this, Java, all right? Remember that you want to add this up here. The reason why I'm asking you to be careful is that this B here is minus 13, okay? So signs matter here in this case. So 1 and 12 is almost correct. What would be our two numbers here? You're really close. It wouldn't be positive 1, positive 12. What would it be? Yeah, that's right. So minus 1 and minus 12. Spot on. Okay. Right, so just be careful about that little hiccup there. That can tend to be a little bit nasty. All right, let's go to step 3. So step 3 is we're going to rewrite the bx term So rewrite the bx term using the numbers you found in step 2. Okay, so basically what I'm doing here is I'm rewriting the problem, okay? So here I have 4x squared. That part's going to stay the same, okay, here in step 3. But now I'm going to rewrite minus 13x in terms of these two numbers here. So I'm going to write, say, minus 1x minus 12x, and then plus 3. Now finally, we can do factor by grouping here. That's the last step here, factor by grouping. Oh, that's okay. Let me go ahead and showcase one more thing here then. So if we factor by grouping, we're going to underline this as our first group. We'll underline this as our second group. And we want to factor each individual group. So we have, okay, that's correct there. This is this 11 o'clock class. I'm just showing off an example for a question I had earlier. There'll be 4x minus 1. Have to be careful about the signs there, Jawa. So you have 4x minus 1, but this minus sign here has to come down. So you can take out a 3. That part is true. But remember that the signs on the inside here also change. So this is 4x minus 1 because a minus of a minus is a positive to get that plus 3. So be really, really careful about those signs. That's actually that's kind of the thing that trips up a lot of people, is those extra itty bitty signs. Okay. I hope that helps. I hope that makes it understandable. And then this would be your final answer. Now, one more thing. I said I would show you a variation. The variation is what happens if you include y's in there, right? So you have 13xy plus 3y squared. So let's say you had this. Well, yeah, no problem. If you have like the extra y in there, well then all you have to do is basically ignore the y. That's basically how you handle this. So the key is ignore the y. Why do you do that? Well, because if you go to the end of the problem after you do the factoring, yeah, that's right. So you'd have 3y here, and you'd have 4x minus 1y here. You just tack on the y's there at the end. That's why the key there is just to ignore the y's. Same factoring, just imagine you just have x. That's it. I promise you that's all you have to do. If you think you have to do more, I don't know what to tell you. All right. So hopefully that helped you out there, Jawa. Hopefully I answered your question. No problem. Okay. Take care, Jawa. All right. All right. Apologies for that there. We're just answering a question there, but yeah, now it's time for us to get started here. So let's go ahead and do that right now. Okay. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today we are going to be doing good morning, Hisa. Very good morning to you. So today, we're gonna be doing the last part of section 1.7. We talked about rounding last time. We just kind of talked about the basics of rounding there. Now today we're going to do the latter half of section 1.7, which is talking about doing operations with rounding numbers first. And then we're going to go into section 1.8, which is going to talk about exponents, square roots, and the order of operations. And I'll probably have to make an announcement here at the end of class. So good morning, Rob. How are you? So I'll make a little announcement here at the end of class in regards to what I announced to the first class there, and what the future plans going forward are going to be starting next week. So no big changes, mind you, but just where we're going to be at in terms of pace. All right. So let's go ahead and get started here with the latter half of section 1.7, and then we'll work our way up from there. Okay, so if you recall from last time here, yes, Korovar. So if we remember from last time here, we talked about how to round numbers. We circled the number that was the digit we wanted to round to. Yes, but if you have a question, please feel free to ask. So we circled the number we wanted to round up or keep the same, and then we tested that number by underlining the number next to it on the right. Okay, so we did the kind of the circle underline approach to doing the rounding method. Now today we're going to be rounding numbers here first, and then going ahead and doing, plus, minus, times, or divide, or whatever we want to do with those numbers there at the end of the day. So let's take a look here at how we can round numbers. Okay, so again, we round each number first, so that's the first note. And number two, we are not finding the exact answer. So that's one of the things I want to point out here is we are not finding the exact answer here for this. All right. So we should get an approximate answer, but not an exact one. Okay. Now, let's go ahead and do a problem here. And I'm going to pick a different one than the last class. So I always like doing different ones, especially when I don't want to like keep showing off the same things. It's boring when you do the same thing over and over. All right. So we're going to go ahead and do this problem down here. All right. And we're going to add these numbers here together. So we're going to go kind of one step at a time here. Okay. Bring this up. Bring this over. Okay. So let's just round here. We're going to round to the nearest 10 for each of these numbers. So we're going to round to the nearest 10. All right. So let's look at this first number here, 16. If we round to the nearest 10, what does 16 round to? All right, 20. Great. That's right. Oh, okay. So far, so bueno. How about 74? 70. Right. Right? Because again, we're taking the 7. We look to the right. That's a 4. All right. And so with, again, that being between 0 and 4, that will stay the same at 70. Okay. How about this next one here, 58? All right. 60 is spot on. Very good. All right. Very nice. And how about 31? Oops. Move that up one there. 30. Yes. Good. All right. So far, so bueno. All right. Very, very good. Okay. I'm liking where this is going, and I approve this message. All right. Okay. So let's look at next here. Next, we're going to add all these numbers together, right? Because that's what we would have done if we were doing the exact answer here. So we're going to add all these numbers together. So we're going to 20 plus 70 plus 60 plus 30. Okay. And again, you could just go, again, just do our same regular old adding here. So we add straight down, we get 0. And what do we get when we do 2 plus 7 plus 6 plus 3? So 2 plus 7 plus 6 plus 3. Just add these numbers here. 2, 7, 6, 3. Yeah, 18. So our final answer here, indeed, is, it's correct, Sion, it is indeed 180. Spot on. Okay. Any questions about that? So hopefully that's so far so good. It's not too bad. Be like, yeah! And I'll be like, yeah! And you'll be like, yeah! Oh my god. Alright, so let's look at the next one here. Okay. So the next one here, let's do, yeah, I'll make up one. I'll make up one. So, okay. Let me go ahead and make up one here. Okay, so let's say we're doing 374 times 549. Again, we're not finding the exact answer here. We need to round each one of these numbers here first. And specifically, we're going to round to the nearest 100. Okay, So let's look at 374 here. 374 rounds to what? What does 374 round to? 400. That's correct. Yes. Right? Because again, we're rounding this 3, that's in the hundred spot, and we're going to look to the number to the right of that, which is that 7 right there. So 7 between 5 and 9, so we'll round that 3 up to a 4 and change the other two numbers to zeros. All right, how about 549? What does that round to? Yeah. 500, like $500. Okay. Anyway, money I don't have. Okay, so what we're going to do next is solve for this. Again, this is multiplication. We're doing 400 times 500. Now here's the nice part. Because we rounded before we actually multiplied, doing this problem is significantly easier. Because all we got to do here is take the numbers that we see here, 4 times 5. So let's answer that question here first. We're going to do 4 times 5. What's that? All right, 20, right? And then any of the other zeros that you see here, right? You see we have 4 zeros here, so we're going to tack on 4 more zeros because we have 4 zeros up here. And so our final answer here is 200,000. So just underlying where we got those two banks of zeros there. That's where we got those two banks of zeros. So 200,000 here would be indeed our final answer. Are there any questions about that? So hopefully that's not too bad. Or maybe you're writing stuff down, so that's okay. Hey, Carissa. What am I doing? I'm not doing anything, I swear. Samantha, I haven't done anything. You keep getting kicked out of the channel? um, uh, so hit F5 to refresh. Or hit the gear to lower the quality to 720. I'm trying to run at 1080p, so it's like, you know, you can see things more clearly. But if your computer, if you have low bandwidth or a low connection, then maybe just lower the quality to 720p and see if that just eases a bit on your computer. Everybody's computer is different, so, and your connection could be different, so I don't know. So, but that's the best suggestion I can make. Is just to, so, you know, it's easier for it to render and stuff. So hopefully that works. Okay. All right. Yes. Okay. Gotta move forward here. Okay. Next. Okay. Next, we're gonna go ahead and do a couple more examples here, but in this particular case, we're gonna do what's called front-end rounding. Okay, so we're going to do what's called front-end rounding. Now, for front-end rounding here, what exactly does that mean? Well, let's go and see what we're working with here. Samantha, did you get it to work, by the way? Hope you did. Okay, so what's front-end rounding? Front-end rounding is you round using the first digit of the number. Okay, cool. So we're going to round using the first digit of the number. All right, so that's front-end rounding. So how does it work? Well, let's take a look at a couple of these examples here, and let's see exactly, how we can approach some of these problems. All right. Okay, so I'm going to do this first one here, letter B, and we'll do it here on the paint tool. I'll shrink that down. Okay, so let's do this, and where is that? There it is. Hang on a second, sorry. I need to erase this. All right, let's go with the blank screen there. All right. So 6712 minus 825. So all we're doing here in this particular case is to go ahead and circle the first digit, all right, that we see here. All right. That's nice. Yeah. Anyway, I'm not sure, but whatever. Anyway, let's go ahead and take a look here and circle the first digit of each number. So we're going to circle the 6 here, and we're going to want to round the 6 because that's the first digit, and the first digit here in this next number is 8th. Okay, so that's what we're going to have here. All right, so let's round this first number here. What does this first number round to? 7,000. Nice. That's correct. Okay. And how about the next number? 825. What does that round to? 800, right? So we got a 2 next to that. So you got 800 here. Again, sorry for the noise there. They're cutting stuff outside, doing some landscaping. Okay, and now we're just going to go ahead and subtract 7,000 minus 800. And can anybody tell me what we get for that? All right, 6,200, spot on. All right, that's correct. All right, so that's going to be our final answer for this problem here, is going to be 6,200. Oops, looks like a mistype there, Samantha. I think you meant 6,200. Okay, let's go ahead and do another one here. Again, let's just do one more example here. So I'm going to do, which one I want to do? Yeah, let's just go ahead and do that one there. Yeah, that's fine. Let's go ahead and do that one there, 725 and 86. So we'll multiply here. Again, we're just going to, we're going to round using the first digit here. Underline what we need to use as a test. Okay. How about this first number here? What should this round to? Okay. 700. That's right. Yeah, I know you just accidentally put an extra 0 there. It's all good. No problem. And how about the second number? How about that 86 there? Okay, that's correct. The answer here is 90. Okay, so again, the reason why 8 here, again, the 6 next to the 8 here means that's between 5 and 9. So we round this up by 1, we add 1 to the 8, which becomes 9, or 90. Now all we have to do is do the same trick we did in the last problem. We're just going to multiply 7 times 9, and then tack on as many zeros as we see here in this problem. So what do we have here? 7 times 9. 7 times 9. 63, spot on. Nice. And we're going to tack on the 3 zeros that we got here at the end. And so our answer here, 63,000, is our final answer. Okay, great. Are there any questions about that? All right, cool. All right, so that is the last part there I kind of wanted to show off from section 1.7 is how we can use rounding to get an approximate answer, rounding first and then going ahead and applying the operator. All right, so that is the end of section 1.7. Let's go ahead and move on here to section 1.8. Section 1.8 talks about exponents, roots, and order of operations. So we're going to talk about today, what exponents are, what roots are, and then the order of operations here. So we're going to take a look at that right now. I want to actually make a change here. Where is it? Yeah. Okay, that's fine. Okay, fine. Yeah, that's fine. Okay, so let's talk about what it means to have a exponent here. All right, so let's talk about some basic definitions, and we'll also talk about we'll look at several examples, of course, as well. So first, exponents. What does an exponent look like? An exponent generically looks like something like this. Something akin to b to the n power, where b and n are some numbers. B is the base of the exponent, what we call the base, or the base of the exponent, and n is the exponent itself. Now, what does an exponent mean? An exponent means basically how many times you will multiply the base with itself. So, what exactly does that mean? Well, let's take a look. So let's say, here's an example. Let's say I had 3, or let's say I had 4, let's say 4 to the third power. Okay, so 4 is going to be our base, all right, and 3 is how many times we're multiplying 4 by itself. So this is going to be 4 times 4 times 4. And that's essentially how we want to do exponents. So if we write it out, it would be 4 times 4 times 4. And then we can go ahead and figure out what that is. And 4 times 4 times 4. Be a little careful here. Remember, 3 times here. So you did it twice. So 4 times 4 here is 16. Agreed. But then you're taking that answer and multiplying it by another 4. So, right? So that's the key difference there, is that, remember, 3 times you're multiplying by 4 by itself. So that's why it's 64 here. So you kind of were part way, and then you just had to do that one extra 4 out there, and that's why we can justify that to be 64. Okay, let's look at another here. How about this? 2 to the 4th power. How would you write out? Oh, that's okay. That's not a problem. That's why we're here to cover this, cover our bases. All right, how about 2 to the 4th power? How could we write that out? How do we write out 2 to the 4th power? Okay, looking good. So we get 2 times 2 times 2 times 2. Okay, so we're multiplying 2 by itself 4 times, okay? Now that, I agree, Samantha, is indeed 16. Absolutely right. So 2 times 2 is 4, times 4 times 2 is 8, and 8 times 2 is indeed 16. Spot on. Nice. Nicely done, everybody. Okay. So again, it's not too hard to figure out, how you can actually evaluate it. It does take, of course, a little getting used to, and some numbers are. How did I get that? I guess. Sometimes it's better to. Sometimes it's better to be lucky than good. But we're going to try and get you to the good part. So, all right, let's try this one here. 5 to the 3rd power. So can anybody tell me what that would equal to? 5 to the 3rd power. 125. All right, so 5 times 5 times 5. So we have 5 times 5, which is 25, and 25 times 5 is indeed 125. A good way for 5s that I always look at for especially powers is 5 times 5 is 25, or a quarter. Well, how much money do you have if you have 5 quarters? Well, you have $1.25. So you get 125 for that. That's the way I actually remember that in my head. All right, good stuff. All right, so those are exponents in general. Those aren't too bad. Takes a little getting used to, but you can see how we kind of break things down and work with them. All right, now we have to look at something else here, of course. So the next thing we'll talk about here is square roots. Now you probably have seen square roots before, but we're going to talk about them here a little. We'll go over this slowly here. So let's talk about square roots here in a little bit more detail. Okay. Now, first of all, let's talk about notation. Now, you've probably seen this notation before. This shouldn't be brand new to most people. If you've probably seen it at least once or twice or something like that, or maybe you used it extensively, I don't know. In any case, you've probably seen this at least once in your life in some capacity or form. Okay. But what we want to do is figure out how to find, say, the square root of a number. Now here, we're going to be dealing with stuff on the basic. Okay, meaning to say, how do we exactly find the square root of a number? So if we want to figure out what the square root of some number is, and I chose a, is equal to some random number, then we need to figure out a question. And that question is, what number squared is equal to that number on the inside of the square root, or equal to a? Okay, so I always constantly ask myself this question. What number squared is equal to that number underneath the square root? So what does that require us to do? Well, let's take a look here at the handout here. The handout here will prove to be very helpful in this case. And we're going to be on page 60. And if you take a look here, here is the perfect squares table. All right. So this little table here will be a very big help for us into determining square roots. Okay, because we can figure out what number squared is equal to that number underneath the square root. So let's go ahead and take a look here, and let's try some examples and see what answers we get here. So we'll try that first one. I'll try one here. The square root of 9. So if we want to figure out the square root of 9, then we want to figure out something squared. So what number squared equals 9? Okay, so taking a look at the chart here, what number squared is equal to 9? Yeah, 3. So that's our answer. The square root of 9 is 3. Okay, let's go with the same premise for other numbers. Let's do that next one that you see on the sheet. Okay, so how about the square root of 49? Again, what number squared equals 49? Yeah, that's right. 7. Exactly, right? You can see here on the chart, 7 squared is equal to 49. Awesome. Let's ramp up the difficulty here just a little bit. How about the square root of 169? So the square root of 169. All right, move this over here, sorry. Boop. Yeah, that's right, 13. Okay, so as we can see here, 13 squared is equal to 169. So that number squared being 169, that'll be 13 in this instance. Now, it may take you some time to memorize this perfect squares chart. This you use this over and over and over again, by the way. So this is something that you'll see quite often. Sometimes this chart here extends out to say 20 instead of 15. But in any case, it's good to memorize this chart because it's used in future classes quite extensively. So having to kind of get to know how the square root works, fairly important. Let's look at that last one there. We get the square root of 0. What is the square root of 0? Yeah. So we still get an answer here for a square root, and that happens to be 0. That is correct. Okay. Any questions about that? Uh, it's not undefined. So for square roots, what you'll learn later on about square roots is that you can't take the square root of a negative number, but positive numbers are okay. So starting with 0, from 0 going on up. Yeah, 0's not classified as a negative number. It's not a positive number either, but negative numbers are the only ones that don't work for square roots. But we're not going to get into that, in this class. So I don't want to add more information than what's necessary. Okay, we're going to work more with square roots here, but let's go ahead and move forward here. We're going to work more on the square roots in this section, so you'll see exactly how that's going to pan out. Let's go ahead and take a look here at order of operations. Okay. Now, before I start talking about order of operations, I want you guys in the chat, I want you guys to answer this question for me. I'm going to type it out here. All right. So, looking at this problem here, can anybody tell me what is the answer to this problem? Okay, I see a couple people. 1, 4. Get 9. Couple 9s, couple 1s. 9. Okay, 9. Anybody else want to chime in? Okay, now let's take a look here and see what the answer is. Okay, I asked this question on purpose for this reason. So the answer to this particular question here, 6 divided by 2 times 3, is going to be 9. 9 is correct. Okay, so 9 is the correct answer for this problem. Now let's talk about why this is the case. Okay, why is it not 1 in this instance? You know, why isn't the other answer? Well, let's take a look here. When we talk about order of operations, we talk about PEMDAS, right? So P represents parentheses, E represents exponents, and M and D represents multiplication and division. Now, what's important about this is when you first introduce PEMDAS, multiplication comes before division, or so you think. The problem is that they're actually the same exact rank. It's the same thing as addition and subtraction. They're the same rank. What does that mean? Well, if you did a regular problem, like instead of like divide and times, okay, if I had 6 minus 2 plus 3, okay, well, you would go from left to right. You would say 6 minus 2, which is 4, and 4 plus 3, which is 7, right? That's how you would figure out that problem. You just go left to right without too much trouble. Okay, easy enough. Well, why don't we do the same thing for the first problem? It's the same exact thing. We go left to right. There's no parentheses, so we don't actually multiply first before we divide. We actually just go ahead, go left to right. So in this case here, we do 6 divided by 2, which is 3, then take 3 times 3, and that's where we can justify the 9 from here in this case. All right, so I'm just pointing out here exactly how we came up with 9 as our answer here. Is I'm not going to treat it any different as if I had minus and plus. I'm just going to go left to right and then roll with it. Are there questions about that? Because that's one of the things I think people got confused about maybe when you learned it the first time. And so we just want to kind of get rid of those misconceptions there. Any questions so far? Nope. I'll talk about that at the end of class there, Alex. The answer is yes, by the way. So but I'll tell you more details at the end of class. Okay, let's go ahead and do some problems here with order of operations. Again, these are our order of operations. Now, I did put a note with the order of operations here, by the way. Square roots, if you do see a square root in a problem, will be treated as an exponent. Okay, so square roots are treated as exponents here. We'll look at several problems here where we're going to see square roots, so we're going to practice more with them. That's correct, Samantha. You go left to right. 6 divided by 2, and then 3 times, and then, which is 3, and then you do the 3 times 3. And that's where you get the 9 from. So you just do it as 2 steps there. So if you do 6 minus 2 plus 3, it's like left to right. You do the same thing there too. Okay. Any other questions before I move forward? No. Okay. Let's take a look at several examples, and we'll see exactly how things work out. Yeah. All right. I'm going to use the paint tool for this, so it's just a lot easier for me to write stuff out. So, okay. So let's look at just that first one you see there, this very first one. All right, so here we're going to get 8 squared plus 5 plus 2. Okay, so let's just go over this slowly here. So what do we do first? Okay, that's right. Let's do 8 times 8, right, for 8 squared. All right, I agree with that. And what's 8 times 8 there? Got to do those exponents first. 64, spot on. And we have 64 plus 5 plus 2. And what do we get here as our result? We add those together. All right, good beans. Yes. Answers are good. Good for you. All right, that's correct. Good. All right, no problem. Okay, let's try this next one here. All right, so again, 9 plus 20 minus 4 times 3. So remember, parentheses have to come first. So that's your nudge, nudge, wink, wink hint. So I'll let you guys take a minute or two. Let's go ahead and give this problem a try. And then once you're done, you can tell me what you got for your answer there. Okay, so you have 45 there. 57. Okay. I'll give a little more time here, so I know for some people it takes some time, so. 75, 57. Okay. Oh, okay. Well, let's take a look here and see what we get for our result. Okay. So, first thing that we have to do here, as I mentioned here, we have to do 20 minus 4, which is 16. That's the first thing we got to do first. Then you have to do multiplication next. Remember, addition subtraction comes last. So you're not working left to right. You have to look at the operator here. In this case, the first operator that we have to do is going to be 16 times 3. We have to do multiplication before addition, so that's going to be 48. And then we have 9 plus the 48, and that justifies the 57, which should be your final answer. So remember, order of operations is important. Okay, you see in this case here, multiplication first and then addition. Okay, so I'm not technically going left to right if I have plus and times. I can't do that. If I have division and multiplication, sure, because they're the same rank. But that's not true for addition and multiplication. Please? 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 Sorry? I'm... did I do something wrong there, Samantha? Apologies if I did. Oh, okay. I was like a little worried there. I'm like, what did I do? Why are you shouting at me? What did I do? I was like, oh my god, I did something. And I'm like, oh, I don't know what happened. Oh well, it happens. All right, good beans. All right, question about that. Ah, okay, yeah. Oh yeah, please excuse me. Oh yeah, please excuse my dear Aunt Sally. Yes. Yeah, that's also very common. Yeah, absolutely. All right, we'll move on to the next problem here. Okay. Whew. Scared me there for a second. I was like, oh my god. All right. All right, let's do this next one here, right next door. And I'll go ahead and write this out here. So we got 12 times the square root of 16 minus 8 times 4. Okay, so let's take a look at this here. Now we have a square root in play. So what happens first here for this? What should we do first? Parentheses, okay. So you want to do 8 times 4 first? The square root of 16, okay, that's exponents there. All right. What's the square root of 16? I don't disagree. Either case is fine. What's the square root of 16 then? 4. Nice. Good. That's right. Now, also suggested to do the 8 times 4 here. So what's 8 times 4 here? That was suggested. You could do that too. Still have to do the square root by itself, but still. 32. Nice. All right, spot on. All right, what comes next? What's next? All right, the 12 times 4, right? 12 times 4 is? 48. And finally, we get 48 minus 32. What's our final answer here? Yep. Nice. 16 is our final answer. Very nice. Nicely done. Nicely done. All right. Questions about that? There. Things. Yeah. All right. Let's have you work on another problem here. So, again, let's take a couple of minutes. Let's have you work on this problem here. So, we'll do this together here after. We'll take a minute or two. Type it out in the chat what you get for your final result here. So 4 squared times 2 squared plus 7 plus 3 times 2. So that's okay, Alyssa. So the homework here for today, um, don't worry, I'll be talking about a few important things here, Alyssa. So stick around for that at the very least. So sections 1.7 and 1.8. So okay, 84. If you see a few 84s here. Ah, okay, you're ahead. You're in good shape. Stick around though for the next 10 minutes. I do, like I said, I do have something important to talk about. So, some important information that certainly you'd like to know. All right, any other answers here? Okay. Okay, so got 84 here. Let's go ahead and check it out, see what we get. All right, let's do this together here. So we got 4 squared times 2 squared times plus 7 plus 3 times 2. So we're going to do the parentheses here first. Parentheses here, this is 10. And we'll also do these exponents here. 4 squared is 16 and 2 squared is 4. Next, we'll do 16 times 4, which is 64, and 10 times 2, which is 20. And so 64 plus 20 is indeed 84. That is correct. Okay, any questions about that? Okay, good. Okay. All right. Now, the next thing I want to talk about here is that, well, okay, I guess I should preface it by saying this. This is pretty much the end of section 1.8. Okay. Now, let's talk about what's going to be happening here for the upcoming days here. So next time on Tuesday, we're going to do section 1.10. We're not 1.9 is not being done, but we're going to do section 1.10, and I will be making an announcement, probably most definitely on Tuesday, that the test over chapter 1 will be due the following Tuesday on the 22nd. So on the 22nd, there is when the test will be due. So to give you a little bit more information, the test will obviously be on my math lab. Okay, that part is true. You'll have a week to complete it. So when I make the announcement, I'll post the test. You'll have a week to complete it. You'll have, I think I'm going to set a time limit, but like a very easy time limit. So maybe you'll have like, I don't know, 3, 4, 5 hours to finish the test. Whatever. Should be plenty of time to finish the test. I'm not going to put like a bunch of questions. So even though I put like a big time limit, doesn't mean I'm going to put like a lot of questions. So I just want to put enough time there where it's like, okay, you can reasonably finish 20 questions in 4 or 5 hours. In any case, I may just end up doing just like one retry. So you do have a chance to retry if you're not satisfied with your score. It'll understand that the test will be posted probably next Tuesday, but will not be due until the following Tuesday after that. So it'll be posted on the 15th, but then it will not be due until the 22nd. Now, one thing to understand is that I will need to see work, so I will be setting up a Dropbox. All right, and I'll be posting that there in the announcements as well. There'll be a little Dropbox there for you to scan your work and then send it to me via the Dropbox. Okay, so I will have kind of that expectation, but since you have a week, it should be pretty easy to go ahead and find something that you can scan with and then send me the work. So it's not like a day or something like that. Yeah, you could do either one as long as it's clear. So that's a great question, Alex. Yeah, if you do the work on paper, take a picture and send it through the Dropbox, then that's fine. Because then I'm gonna take a look at that, and as long as the picture's clear enough for me to read it, then that'll be perfect. This will be starting next week, yeah, next Tuesday. So because we'll probably finish section 110 next time. Right. So what I'll be doing is I'll be posting an announcement here in class. Oh, thank you for the follow. I'll be posting an announcement here in class, and in relation to that, so to give you a nice heads up here, you'll have a full week to finish it, and there you go. Yes, so on chapter 1, everything that we've covered here in chapter 1. Yes. Now, what I'm going to be putting up as well, just to let you know, I'll have a little practice test as well. So that practice test, you can, you don't have to like jump into the test right away. You can practice with the problems that will probably be on the test, and then you can see what you're working with. So you don't have to jump into the frying pan necessarily. Try the practice test out, and then see, and then if you get comfortable with the kind of the formatting of MyMathLab and all that stuff, you'll be having that. Checking homework. Okay, good question on the homework there. Now I don't need to see a scanned copy of your work for homework. No, I don't need that. I just want the scans for the test, all right, showing me the work behind that. For the homework, however, in relation to that question, Carissa, what I want to point out here is, so I will type this out here. The homework for chapter 1 is due on basically due the same day as the test is due. Okay, so basically, if the test is due on the 22nd of September, all the homework for chapter 1 will also be due on that very same day. Okay, so I'll be setting the due dates there and all that jazz. So that way you're just working on the stuff that is just for chapter 1, and then it'll be relevant to just that part there. Yeah, any of the homework that you do will be saved to MyMathLab. So I'll take a look at that myself underneath like the gradebook and stuff, and I'll make the adjustments as necessary. So that's a me end once the due date has passed for the chapter 1 homework. I'll then take a look at the gradebook, see what you did for the chapter 1 homework, and I'll put in the scores appropriately in the gradebook on D2L. So that'll be a me thing. But the test is a little different because I want to see what your progress is for showing me the work for the problems. So so you don't need to upload it to me. I'll take care of that manually. No. So no 9-1, 9-2, 9-3, just only chapter 1. We're going to do chapter 9 later. Yeah, so that's all my expectations going to be there. Okay, that's fine. If worst comes to worst, just give me another heads up on an email, and then we'll work something out there. Okay, Carissa, I don't have a problem doing that. So I have an alternative just in case if things don't work out that way. Okay. So basically, what I'm trying to say is that if worst comes to worst, and because of financial aid, and because of all the nonsense, if you need it like right away, if you need it right away, Carissa, I'll just I'll buy you a code out of my own pocket, and you can use that there. Take care, Alyssa. Rob, you have a wonderful day. I'll just pay for the code out of pocket, and that'll be it. So, because I know you want to kind of get started, or if you've made a temporary account at the very least, until you get the access code. Any other questions? Thank you, Sion. You have a wonderful weekend as well. None from you? Okay. All right. If nobody has any more questions, I'm going to be talking more about the test here on Tuesday, so I'll add a few more details here. Yeah, I know. No, no. If, like I said, I want to be sure that you have peace of mind. Like in case if, like I said, if worst comes to worst because of circumstances you can't control, then yeah, like I said, I can easily cover the cost. It's not a big deal. So, am I? Samantha, the real question is, would the real question is, are math assignments trying to kill you? Period. And will they all just kill you? Period. As a math professor, the answer is always yes. Waiting for you to get your check from work, okay? To get your my math lab. Okay, that's true. Okay, that's fine. That's fine. You just keep me posted as well, okay? In terms of when you get your my math lab access code and stuff like that. And I'll extend the same offer to you if worse comes to worse. I'll cover your cost for your access code. Anything else? Any other questions? Yes, that's correct. Hey, look, circumstances are sometimes beyond your control. Like, look, who's going to say that the coronavirus was going to last this long? You know, so we're at this stage here, and I don't mind. I got some spare. I got money to spare in that regard, so that's fine. I'm more than happy to help. It's all that matters to me. So, anything else? For Tuesday, yeah, we're gonna be doing all of 110. Yep. I have office hours after this class. Not after every class because I have a class before this, which is same class, same Math 90, but still, you know. Okay, no problem. Feel free to email me the question, okay, Samantha? You can contact me via email or the discussion board on D2L. I know not nobody really uses that, but email me and I'll get back to you if you need more help, okay? Are we do Yeah, homework, just save the homework there, Hisa. Okay. So your brother and his friend want to know what games I play. Okay. All right. You got me. All right. Let's let's get on the good old Steam account. If we're gonna do a game, I'll do a fast, quick game of Fall Guys. I play a bunch of different types of games, so Fall Guys. Let's see. Played Town Salem and stuff like that. Hisa, you have a wonderful afternoon yourself. You have a great afternoon. I'm not very good at Fall Guys, but yeah, a couple of times. Though I don't really ask for donations because I would think that I would think I would think that I'd be at least helping out. You know. You have a wonderful rest of your afternoon too. You take care of yourself, all right? I don't know if I deserve. I don't know if I actually, necessarily deserve donations, but look, man, I'm not gonna force you to give me money. That's wrong. I can't. I couldn't do that to you. I what you do with your money is your business, but if you'd like to, then it would be appreciated. But man, I don't know how I kind of feel bad too, because if he's saving money and stuff. Ah, man, I've only received 2 donations on this stream, like $1 and $5. So it ain't a big deal. I'm just happy I could be of help and educate people. That's really what it's about. If I'm able to help you, Kaner, then that's great, man. That's all that matters. Oh, I got ragdolled. Holy smokes! Thank you, I appreciate that. Like I don't do this for I don't do this. I'll be live later tonight. Yeah, I will be. I have one more class at 4 o'clock, Central Time to 6 o'clock, and I'll have office hours right after this. So get in. All right, get in. Yes. But yeah, I mean, I I don't do this job for the money. I do this job because it's my contribution to society, and I legitimately have a lot of fun with it. The money is there, it helps me live, yes, but I don't need a lot to live. I just do it for the funds and the lulls and the funds. I don't play COD, actually. I don't play Call of Duty. I'm just not a Call of Duty kind of guy. I hope that's that. I hope I play a lot of different. I, to answer your brother and his friend, yeah, I play a lot of different games and stuff. It's it kind of floats all over the place. I'm pretty casual, so that went boo. Come on, good boy. Bum, 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 bum. That was a bummer. Yep, yep. Got it. Nice. You play zombies? That's awesome. Zombies are cool. I play this game, like Ted Sim, Baldur's Gate 3 I'll be playing, Cyberpunk 2077, Fortnite. Fortnite I haven't. Wow, I only played like one game of Fortnite ever. Warzone, I've never played Warzone, though a lot of people like Warzone. I played PUBG a few times. I didn't really like it too much. It wasn't that great. Um, on a positive note, I have a 2070 Super in my system. I mean, that's not bad. Man, Slime Climb. Oh, this game is actually really hard. Slime Climb is actually rather tough. People like the Fortnite stuff. I said that's cool. Meh, 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 meh. Oh, that's so mean. Oh, crap. Dang it. Oh, I'm gonna die. Oh, how did I not miss? How did I miss that? Okay. I kind of have no idea what I'm doing right now. Oh, crap. The slime, it's coming. Run, 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 run. Oh, crap. Oh, I died. Darn. uh, have a great one. Have a great weekend. Take care of yourself. Oh well. All right. You have a great rest of your day yourself. Always for the lulls, let me tell you. Oh man, too much fun. All right. Does anybody else have any other questions? Otherwise, I'm going to go to office hours. If you do have a question, I'll take open questions. Um, but otherwise, if you do have office hours from 12:30 to 3, just please go ahead and email me if you do have any questions, and I'll come back online and answer them for you. Okay. All right. Great. So I will see everybody later. Thank you very much for coming out and to the stream once again. I hope you learned something here today. And I will see you later on in the day if you're coming back for some college algebra. If not, I wish you all a wonderful weekend, and I will see you on Monday if you're not coming back then. So, all right. Have a great day, and we'll see you in a little bit. All right. Bye. We'll see you in a bit.